Hello and welcome to another episode of A-Learning. Today I will be teaching physics and I will be dealing with two confusing topics. Induced force and induced EMF or induced current. Now in my experience, I find that students very often get confused with induced force and induced EMF. They are very different and very often students are very muddled with these two topics. Now these two topics are part of the Physics 0625 syllabus under electricity and electromagnetism. Now let's first start with induced force. When we say a force is induced, we mean that a force arises or a force comes about. So in physics, a force is induced when two or more magnetic fields overlap in the same region and they interact to induce a force. So in IGCSE, the magnetic fields come from very often a permanent magnet and a current carrying conductor. So when the magnetic fields of the permanent magnet and the current carrying conductor overlap in the same region, we get an induced force. So the induced force acts on the conductor and the direction of the force is according to Fleming's left-hand rule, whereby the index finger represents the direction of the magnetic field, the middle finger represents the direction of the current, and finally the resulting direction of the thumb is the direction of the induced force. Now let's look at this example that we see. Alright, we see the magnetic field coming out from the permanent magnet. We see the current flowing through the conductor. So you get ready Fleming's left-hand rule. You align the index finger in the direction of the magnetic field from north to south. You align your middle finger with the direction of the current, and finally the resulting direction of the thumb is the direction of the force acting on the conductor. Moving on to induced EMF, which in turn induces current. Now in physics, when a conductor is moved physically across magnetic field lines, or we say the conductor cuts the magnetic field lines, in this case, current is induced. Usually the magnetic field and the magnetic field lines come from the permanent magnets. As the conductor is moved across the magnetic field lines or cuts the magnetic field lines, the flow of induced current is according to Fleming's right-hand rule. Now, the index finger represents the direction of the magnetic field from north to south. The thumb represents the force or the movement of the conductor, and finally the resulting direction of the middle finger is the direction of induced current. Let's have a look at the next example. Get ready Fleming's right-hand rule. Firstly, align your index finger with the direction of the magnetic field lines from north to south. Secondly, align the thumb with the movement of the conductor. And finally, the resulting direction of the middle finger is the direction of the flow of induced current. So that was how you find the direction of induced force and induced current. Now, as I've mentioned earlier, students get confused with induced force and induced current. Now, in summary, an induced force arises when there is power supply. When there is current being supplied to the conductor, it is usually an induced force question. However, when there is no power supply, when there's no current flowing, and you have to move the conductor to induce a current, now that is an induced EMF question. Well, that's all from me. I hope that you have learned a thing or two. Thank you for watching. Bye-bye.